Good afternoon, everyone. It is my pleasure on behalf of the Department of Geography and Geology and the Quality Assurance Unit to welcome you to this afternoon's guest lecture. Our speaker will be Professor John Rodgers, Professor of Geography and Geographical Information Systems at Mississippi State University. Professor Rodgers obtained his PhD in Geography in 1999 from the University of Georgia and has well over a decade in experience in teaching and conducting research in the fields of physical geography and GIS. His current research has been focusing on the distribution of the invasive Australian pine, Casuarina equisetifolia, in the Bahamas and coastal marsh habitat change along the northern Gulf Coast. We're very happy to note that he was a recipient of the 2014 to 2015 College of Arts and Sciences Teacher of the Year Award. So in summary, he has research interests in invasive species, coastal processes, and GIS. Professor Rodgers will address us this afternoon on the topic of rainfall variability on San Salvador Island using community engagement to monitor climate change. Ladies and gentlemen, staff, colleagues, friends who are joining us from all over the Caribbean, please welcome Professor Rodgers to give us his presentation.
Thank you, Dr. Edwards. First, can you hear me? Am I coming through?
You're very clear. And
great, thank you.
Yes. Yeah.
Before I begin with the presentation, let me just mention that I am delighted to be a part of the QAR team reviewing the Department of Geography and Geology. And over the last 4 days, I've just been blown away by how great things are at UWI. I'm very impressed with your faculty and students and the organization. And so it's been an honor to be part of this process. And thank you for having me here today in addition. What I'm going to do now is attempt to share the screen to show my PowerPoint. So give me a second. Is it sharing?
not yet, but you should be able to share because you have co-host. Let us just see. You should be able to share because you have host privileges. Yes, you're starting to share now.
Great. Ooh. Okay. Thank you for that. Oops. So I'm going to be speaking today on a new project that was started in 2018, and it involves the rainfall variability on San Salvador Island in the Bahamas using community engagement. This is collaborative work that I'm doing with a colleague of mine, Dr. Chris Furman, and a student, John Wells. And so before I begin that, just a short bio. I didn't realize I was going to be introduced, but I provided a bio for myself. Anyway, I have an undergraduate degree in biology from the University of Tennessee, a master's degree in botany from the University of Tennessee. I got my PhD in geography with specific interest in biogeography in 1999 from the University of Georgia. I have been a faculty member at Mississippi State University since 2001, and I took over as the head of the department in 2017. I do research in coastal vegetation, invasive species, climate, and geospatial sciences. I just want to mention where I am. I'm at Mississippi State University, and we are, I don't know if you're familiar with university systems in the United States, but we are a land-grant institution, meaning that we have a mission to do applied research and provide a sense of extension to the community. So we're mostly known for like agriculture, forest resources, and engineering. But the college that I'm in, College of Arts and Sciences, is an integral part of those missions. So anyway, we're a land-grant institution. So this is the map where I am, coming to you here from the middle of nowhere in Mississippi. You can see several thousand kilometers from where you are. Just on an aside, when I got the initial invitation to do the QAR, I got my hopes up that there might be an opportunity for a campus visit to Mona. But anyway, virtual is fine, but I would rather be there in person, I suppose. Our department is the Department of Geosciences, and it has a lot of similarities to what you guys do at UWI. We have geography, geology, geospatial sciences, and we also have atmospheric sciences. And atmospheric sciences is one of our biggest undergraduate programs. It's probably the majority of our majors are in meteorology. All right, with that stated, I just want to talk a little bit about this current research project, which has evolved through a number of steps. One of the things that you're probably well aware of, I mean, especially given your location, is that the forecasts due to climate change, at least the models that predict climate variability in the future, show decreasing precipitation, especially in your region. And again, this is no surprise to you all. I'm sure you know this intimately. For instance, if we look at the IPCC, this is from the AR5 report. It shows that the precipitation in the West Indies is forecasted to become drier. In addition to that, the evaporation minus precipitation is also going to lead to a much drier condition. And so this was echoed in the AR6 report from the IPCC. And so the Caribbean region really stands out as being one of those regions that's not only going to get hotter, but also going to be drier, which is obviously not okay. It's an issue that many of you, I'm sure, are very concerned about and know a lot about. So for my interest, I'm interested then in, given this climate change, how does that affect the in situ local variability in precipitation? And so what are, in my case, working in the Bahamas, what are these intra-island precipitation variability? And in this paper, or this presentation, we're really looking more on the methodological approach. How do we record data to measure this intra-island variability, especially given the significance of precipitation and knowing that precipitation is inevitably at least forecasted to become drier over the years. And then can we use this intra-island variability to refine or maybe develop water budgets specific to a location? So really, there are two parts. First one is looking at this intra-island rainfall variability, but also embedded in that is more of a social side of things, looking at some of the successes and failures of using community engagement and citizen science to record rainfall. For background, I have been doing research on San Salvador Island in the Bahamas for a number of years, started in 2001. And San Salvador Island is located in the central eastern portion of the Bahamian archipelago. Just as reference, Nassau is located on New Providence, and so San Salvador is located just south and to the east of Nassau. The island itself is fairly small. It's only about 20 kilometers on its longest axis north to south, and it's only 10 kilometers or so on the longest axis from east to west. And my familiarity with San Salvador Island comes from working with the University of Bahamas and the Geology Research Center, which is an area where I've been able to conduct research for years. I've been looking at invasive vegetation, and then through a series of circumstances, it led to a study of climate. But anyway, my familiarity with San Salvador Island and the Geology Research Center is really what sparked this research. I take students to San Salvador Island, at least I did pre-COVID. I'm hoping to go there again this summer if conditions allow. And so part of the task that when I'm in the field, is to talk about physical geography. So anyway, that's again how my familiarity with San Salvador Island is. It is inhabited. There are 1,000 residents, but it's not one of the most populated islands. It's kind of like one of the it's called an outer island or a family island. San Salvador Island is also known to be the landing location for Christopher Columbus. And so there's a lot of archaeological evidence that points to this particular location where Christopher Columbus made landfall. All right, so continuing with the background, you probably are familiar with this. The climate of the Bahamas is categorized with the Köppen system as a tropical savanna. And what that means is that obviously it's warm year-round. In terms of the precipitation patterns, the Köppen system classifies the precipitation as having a seasonality, so that the summer season has twice the amount of rainfall as in the winter. So it's a ratio of about 2 to 1. So 2 units of rainfall in the summer to every 1 rainfall in the winter. So I'm pointing to this graphic, which comes from a textbook called The Bahamian Landscapes, 3rd edition, written by Neil Seeley. And the data are for Nassau, primarily recorded at the Nassau airport. But the overall trend, as you can see, is that the majority of the precipitation occurs in the summer months. And again, it's a ratio of about 2 to 1. So using data from that publication, I created a map of rainfall patterns across the Bahamian archipelago. And one of the things that you'll notice is that the northwestern islands are considerably more wet than the southeastern islands. And there's a gradient of moisture from northwest to southeast. And there are a lot of reasons to explain that. Probably the most important ones are that a lot of the northern islands receive frontal systems coming off of North America, cold fronts, warm fronts, and so on. And then the further away these islands are from North America, the less likely they are to receive fronts. But maybe even more important than that, many of the islands of the Bahamas in the northern section have a shallow bank, an extensive shallow bank surrounding it. And the shallow water surrounding that island allows for evaporation and then subsequent precipitation. And so the islands that are smaller and on their own small bank do not have enough shallow water to really generate as much precipitation as some of the islands up on the north. So if we look again at precipitation in the Bahamas, a lot of it is generated from synoptic scale systems, larger systems, such as the extratropical systems coming off of North America, like fronts, and then tropical systems. So given that these systems are large in scale, they're synoptic, the question I've always had is, why is there intra-island variability? In other words, these systems are bigger than the islands themselves. And theoretically, or at least in practice, it seems like the precipitation should be more uniformly spread out across the island. Furthermore, in the Bahamas, there aren't many topographic features to really cause any kind of orographic uplift or anything like that. Compare the Bahamas, for instance, to the island of St. Kitts. There's an enormous volcano, Mount Liamiga, that will create its precipitation. But that orographic system doesn't exist in the Bahamas. They don't have that topographic variability. And a lot of the residents on the Bahamas will often state anecdotally that they have noticed differences in rainfall. The north of the island is always wet. The south of the island never gets rainfall. We've seen a decrease in rainfall. We've seen an increase in rainfall and so forth. So there's a lot of anecdotal evidence to say that there is variability. And so my interest is trying to look in and explain that. Why would there be that variability, considering the islands are small and the systems are large? And also knowing that there's a forecast for a drying climate that could, how does that relate to forecasted climate change? There are small local processes that do generate precipitation on these islands, such as convection. And many of the islands can get convergence of sea breezes. And so the sea breezes coming in on either end of the island can converge along the axis or the spine of the island to cause precipitation. But even still, there are differences between, say, the north of the island and the south of an island. So that's one of the things that I wanted to investigate and explore along with my colleagues. And again, it's important to understand this because the precipitation patterns are linked to the water budget. I mean, there are, obviously no major reservoirs of fresh water in these type of environments. And so they rely extensively on precipitation. There are aquifers and they're, groundwater, but unfortunately, in a lot of cases, the groundwater has been overtaxed and overused, and there's salinization of the groundwater. So really, the precipitation is one of the most important factors for developing the water budget for these islands. And so looking at the spatial and temporal variability within the islands is important. And then also being able to use that data to understand the physical processes that are related to it. So the key question in doing that is, how do we measure precipitation? And so there are a lot of ways that exist to measure precipitation. For instance, you can measure precipitation with radar. And so there's a lot of machine learning and artificial intelligence to compare rainfall amounts to images from radar. Obviously, there's some challenges with that. In particular, radar is not uniformly available. So I think the Bahamas really only has one major radar station, and that's at the airport in Nassau. I mean, I could be wrong, but I haven't seen any. But I think that the only major radar station is in Nassau, which is not, in the center of the Bahamas, and therefore islands that are distal from that aren't able to. It's not as important to islands that are further away. The radar has coarse resolution, and furthermore, islands like San Salvador that are on the eastern fringe of the Bahamas, much of their weather comes from the east. And so there's no radar in the middle of the Atlantic Ocean to give them an idea of what's coming. So the radar is west of them, and therefore maybe not as useful. There's also satellites, and satellites are really good, and they're getting better. The resolution of a lot of the NOAA satellites have improved over the years, and there are continued projects using machine learning and artificial intelligence to relate satellite imagery to precipitation. But one of the challenges that face on an island like San Salvador is the resolution is very coarse. And to kind of pin it down to a specific locale can be a challenge with using satellites. Then there's automated measuring systems such as the weather stations. This is my colleague, Chris Furman, who has helped with this research. And this is a weather station on San Salvador Island. The challenge with weather stations are, well, for one, they're expensive. They're not easy to deploy everywhere. They're very difficult to get the equipment. And so you just can't get a lot of them deployed, and therefore you're not able to get a high degree of spatial variability. I mean, to look at spatial resolution. So there may be one or two of these stations that you can deploy, but that's going to cost thousands of dollars. And so, that's a problem. Another issue, and maybe this is unique to the Bahamas, but the conditions are not suitable for electronics. So my friend Doug Gamble, who used to collaborate with UWI, I think he still does, but anyway, he deployed that rain gauge using what's called a tipping bucket methodology. And this is an example of some of the frustrations that he experienced with these tipping buckets. The tipping bucket, when you get precipitation, it falls over, and then the device catches it and records how much the volume of what fell over. But this has a lot of electronic components to it. And in San Salvador Island, there's a lot of salt deposition from salt spray, a lot of intense solar energy, hurricanes, and many other things that make this system fail. And it's very frustrating to deploy this expensive equipment, come back, and next thing you know, it hasn't been recording data for the last however long because it has malfunctioned or there's been some sort of problem. And again, it's not ideal. So there are ways to measure rainfall, but none of these that I've talked about so far are ideal for looking at local or extra local scales. So the question is there a better way to do this, a better way to measure precipitation such that we can get a better geographic spread so that we can get more consistent recording and not rely on machinery that breaks down? But more than that, can we get a system that helps us also get the community to buy in on the importance of precipitation? Because the community, obviously people have to be involved in monitoring precipitation and be aware of precipitation because of the water budget and the importance of that to the region. So we have been associated with what's called QARs, which is the Community Collaborative Rain, Hail, and Snow Network. And I'm not sure if you're familiar with QARs or not. It was started at Colorado State University, and they have a extensive atmospheric science program. They're also the ones that do the forecast for the hurricane seasons. Anyway, the faculty at the Colorado State University have developed this online reporting system, and it relies on citizen science and community engagement so that people, average people, just normal who have a rain gauge and interest in this, can record data and upload it. And then here we have a system where we can download data and record data. And so the idea here is that if we use this QAR system, we'll be able to get extra local resolution of precipitation variability, so that we can then study this and look at how precipitation varies, which again is very important for understanding the water budget. So QARs and Henry Regis, who developed it, has been trying to get lots of different countries involved in this. There is a buy-in fee, and so it's not free, but anyway, the fee goes to the staff and the servers and so on. And so Dr. Regis has been throughout much of the Caribbean. I'm sure he's been to the Bahamas, he's been to St. Kitts, he's been to a lot of places trying to promote it. I'm not sure where these other countries, including Jamaica, are with QARs, but I know the Bahamas bought into this program several years ago. And so the Bahamas bought into it, and the Bahamian QARs unit acquired a lot of rain gauges, and they brought them to San Salvador Island, the research center, and then just through dumb luck, the station director asked me if I would be interested in deploying these, and certainly it was an interest of mine looking at climate variability, so I took on the challenge. I also want to say that did get a small grant through the 100K Strong Partners of America to help to support the travel to do this. And so much of this talk is looking at the deployment of these QARs stations on San Salvador Island. Now, first off, I'm going to admit that when I packed to do this, I grabbed my wife's hat instead of my hat. So the picture looks silly. Sorry about that. Once I got to San Salvador Island, I was unable to get a hat. So anyway, that's my wife's hat. It worked well, but anyway, I just am embarrassed by the photograph. Anyway, so in 2018 and 2019, I went on this campaign to deploy QARs on San Salvador Island. It's fairly simple. I mean, all it is a post and a rain gauge, and just being able to record the location of it and get people to buy in to recording precipitation. So I created flyers, went around the community. This picture up on the top is part of the QARs Bahamas. And so anyway, I adapted that to show that the country was bought. This is a government supported thing. It's not just me coming from Mississippi State University, but this is their government, and I'm just assisting with this process. And so I put flyers out and deployed rain gauges. In some cases, they were in inhabited areas. In other areas, I put them by roads where I was hoping people would drive by. There are a lot of students that go to the Gerace Research Center, and I was hoping that maybe on their way to a particular site, they would stop and report any precipitation encountered in the rain gauge. And so in total, I deployed 8 gauges, and I had marginal success with the 8 gauges. Of these 8, really only 3 have consistent reporting. So here's what had happened is I put these 8 gauges out, and we were able to get people to consistently report. The ones with the circles are the ones that are more consistent. They're cataloged, and then every day at 7 in the morning or thereabouts, island time, they report the precipitation. And so there's specific guidelines to putting this out, and in terms of where they need to be. They can't have tree cover, they can't be close to the house, and so on. I say that, but this particular person, who is an expat, is an older person, didn't want to walk very far to read the gauge. So anyway, put it closer to her house. Anyway, with these rain gauges, the people have been recording rainfall, especially 3 of them have been consistently since 2018. It's not perfect. There's a lot of reasons why people haven't. The benefit of this CoCoRaHS, again, is it's inexpensive. It can improve the spatial coverage, and it allows us to have community buy-in to understand the importance of recording precipitation. Now, I am going to mention it's not a panacea. It's not a perfect thing. There are lots of issues that occur with using CoCoRaHS, and these are just some of the issues that show. So it's not perfect. One is that there's observer bias, and certainly people don't record it evenly, or they have different ways of recording or seeing, and so it's not greatly consistent. There's also consistency of reporting. Some people report all the time, some report only when it rains, some people report whenever they feel like it, and so it becomes, that becomes a challenge too. So again, it's not perfect. There are some challenges with comparing it equally with other observations, such as tipping buckets or from satellite measurements. The willingness of the participants, it's hard to get people to buy in on a daily basis. And one thing I want to add is that reporting no rainfall is as of equal importance as reporting rainfall. So we not only want to know when it rains, but we want to know when it doesn't rain. And that's having a blank is not good. We'd rather have a zero than a blank. Another challenge is it requires the input through Wi-Fi and cellular systems. So people have to have access to those things in order for CoCoRaHS to work. And through all that, we were able to get 3 good recording. One of them is in what's called the United States. They call it UE. So if I say UE, I don't mean UWI. I'm referring to United States, a community on San Salvador Island. And then the other good ones are on the Gerace Research Center, one in Coburn Town, Long Bay, sorry, and then one in what's called Sandy Point on the south end of the island. So what I'm gonna do now is just show you what we've been able to get with these data. And so the question is, does it work? Well, here's some interesting things that we've been able to find. I'm focusing primarily on the one at the United States. And the reason is this person is a teacher. She's extremely diligent, probably one of the best there are in the whole world for reporting precipitation. And so what's interesting to us is that even though this is limited data, it's only 4 years, but we have seen a decrease in the annual precipitation since 2018. Now, again, that fits somewhat with the climate change models. There's a lot of things that go into that. It's not just that simple, but still, this trend does seem to suggest that there's somewhat of a drying trend. It may not necessarily be drying per se. There's, again, a lot of factors that cause precipitation, like, for instance, tropical cyclones. And so we know that, like, for instance, in 2018 and 2019, they were very active tropical cyclone years, and probably that's capturing some of the, or at least resulting in some of that precipitation. But again, what's interesting is with the CoCoRaHS and just really this one station, this gives us some, some data that we're able to look at it and possibly expand upon to understand how the precipitation is changing in that region. If we look at the CoCoRaHS data for other areas in the Bahamas and compare it to Freeport, Nassau, and Exuma, we also see some interesting trends. For instance, Freeport and Nassau are more northly located in the Bahamian archipelago. And what's interesting is that the trend is different than in San Salvador and Exuma. For instance, if you look at Freeport and Nassau from 2018 to 2020, their precipitation generally increases, especially for Freeport. If you look at San Salvador Island in the gray block, it's different. One thing that is interesting overall is that 2021 was much drier than any of the 3 years previous. Again, some of this is probably related to the activity of tropical cyclones. And again, 2018 was a very active year. There weren't any specific storms that hit San Salvador Island, but there were a lot that were nearby. 2019, for sure, there was hurricanes that hit the region. In particular, Hurricane Dorian caused some significant damage. And so, there are tropical cyclones that do explain some of that precipitation trend. But what we found interesting with this United States is that the 2-to-1 ratio of precipitation to summer to winter didn't exactly pan out, that there was a lot more variability than than what one might expect. So for instance, in looking at the average, we saw much wetter May and much drier June and July. We also saw wetter falls. And again, that may be related to the tropical cyclones, proximity of tropical cyclones, but still that trend did not match what we were expecting. And if we look at that, again, one particular station, we look at it year by year, 2018, 19, 20, and 21, we see quite a lot of variability, more than what we would expect. Again, the model is that we get more rain in the wet season is the summer, but what this particular station says is it's much more complicated than you would think. The next thing we did is we looked at the precipitation events and looked at weather charts from NOAA, went back and looked at what was the cause for that precipitation. We categorized it into these different groups based on the synoptic climatology, such as cold fronts, warm fronts, and so on. And what we found that was surprising is that when we look at the precipitation causing mechanisms, again, this is at that one station, most of the time it was associated for what we call non-synoptic events, which means there was no major pressure system within 500 kilometers of San Salvador Island. And so we look at the island and we look at all the systems, in the region, and we measure the distance using, geospatial methods. And we're able to see that, at least more than a third of the precipitation events were associated with non-synoptic events, which again is somewhat of wasn't a shock per se, but it was something that we didn't quite expect. And then you can see there are various other patterns that, like for instance, stationary fronts were the ones that caused the second highest amount of precipitation, not necessarily tropical cyclones. And so that was interesting. In the Bahamas, the stationary fronts often occur because a cold front will encounter trade winds, and the trade winds blow the front backwards across the island. So that's one of the things that generates a lot of precipitation. Anyway, the moral of the story is that we found that there wasn't an easy way to understand the precipitation. It was much more complicated than what we had envisioned. Another interesting thing is we have two really good stations, though good meaning they report regularly, one at the Geology Research Center and one at UE. And so we would expect that because they're only about a mile, it's in US distance, or about 2 kilometers, then we would expect that there would be about the same amount of rainfall. And what was interesting to us is of the days that had measurable rainfall, only about half of the time was that true, meaning that the other half, more than half really, of the time, it either rained at one or the other. It didn't rain at both. And so we could compare the days between these stations and look at when they report rainfall and when they don't. And again, it was surprising to us that there would be that variability in such a short space. And so if we look at the Geology Research Center station, it reported 35% rainfall without UE. And if we look at UE, it reported 16% of the precipitation without the Geology Research Center. So there is a lot of variability, more variability than what we had expected. And then if we look at comparing the north and the south, that 41% time of the station in the north had precipitation alone, where the south didn't. And then looking at the opposite of that, about 18% of the time it rained in the south versus the north. So again, we see this precipitation variability that we may not have been able to capture using other means. Now, granted, again, there are a lot of issues with CoCoRaHS, but it is interesting to see this result. And then we looked at other factors as well, like comparing the non-synoptic versus frontal, comparing the Geology Research Center in the UE, which are only 2 kilometers away, Sandy Point, which is on the south end of the island. And so it's interesting that the precipitation generating factors, those events, are different as well. And so putting all this together, it shows a much more complicated much more complicated pattern than what would have believed otherwise. And so really drawing on some conclusions here, it is, again, not perfect, but this community science using the citizen science to be able to collect rainfall did seem to work. I mean, it did provide us with some answers to some questions. Again, it's not perfect, but it does allow us to capture some of the variability that we may not have observed otherwise. There's still some challenges. For example, we still need to do a better job at getting the community to buy in. I put out 8 stations and only got 3 to report. And so one of the things we're trying to figure out is why are other people not wanting to do this? What are the roadblocks to reporting? Is it just lack of interest? Is this due to the technology? Is this that they, for one reason or another, we just don't know. And so we're trying to look at kind of what are the roadblocks. And I think part of that is I started the project in 2018, 2019, and obviously I wasn't able to get back in 2020. I haven't been back since 2019. So a lot of the relationships that I have with some of the locals and discussions and conversations about the importance of COCORAs were lost. I mean, obviously COVID was a much bigger deal at the time and still is, but still that pandemic and the absence of being able to get back and try to get people reinvested in this really may have been a factor in decreasing the community buy-in. So hopefully the pandemic goes away and hopefully we can get back and start again discipleship for the COCORAs. I also think that there's there's enough evidence to suggest that the COCORA system is useful and works, and so therefore we want to try to make this a much more broader campaign, not only in the Bahamas but maybe throughout the region. And so I don't know if there's any opportunities for Jamaica or any of the other areas nearby you, but certainly this might be something that you had conversations with already, but it may be something, if you haven't, that would be of interest. So anyway, I was excited to see the data, and I think that this could be a good way forward. You get community buy-in and so on. So again, moving forward, I'd like to set up more gauges, and hopefully without having to be, without COVID. I'm doing a new project in the island of St. Kitts, working with Clarence Fitzroy Bryant College, working with some of the faculty there to do water budget stuff. We got a small grant to go there in 2020, but obviously that didn't work out. But anyway, we're looking at maybe bringing the COCORAs to St. Kitts, or at least explaining to whoever it may be about the importance of this and maybe why they might want to buy in. So in conclusion, I just want to thank the sponsors. Again, it was sponsored by the 100K Strong grant. I want to thank the government of the Bahamas and COCORAs for their relationship and being able to set this up and get the rain gauges, and also providing us access. Also, the Gerace Research Center for supporting this, the observers on San Salvador Island. Obviously, we couldn't do this without them. They're the integral part, the most important part of this system. And then to my home institution that also provided some financial assistance. And so with that, I am happy to entertain questions. And I don't know the best method to do this. You're welcome to jump in one at a time, or if I can figure out how to get the chat going again, then we can do that. But anyway, thank you for your attendance today, and I'm happy to take your questions.
Oh, thank you very much, Professor Rodgers. I will help with the moderating, so I will look in the chat, and I will also see if there are any hands raised from among the participants. But let me lead in saying thank you for a very interesting presentation.
Thank you.
Dr. Steeman will agree that citizen science seems to be trending, because one of the presentations that we were in this afternoon was from a new lecturer in the Department of Life Sciences, who was presenting work on involving communities in Australia in her participatory work, looking at river systems and impact on the Great Barrier Reef.
Huh, interesting. I'm going to stop sharing. I hope I don't close out. Anyway, I see a hand, but I'm going to stop sharing. If I close out, I'm so sorry.
So,
yeah,
right.
It worked. Woo.
Dr. Byrne from our department has a question for you. Mike,
Sure.
you can go ahead.
Hi, thank you, John, very much for a fabulous talk, a really interesting talk as well. I have really just two questions. One is, we have quite a good distribution of meteorological stations here in Jamaica, but as always, there are gaps within that network. And so I wondered whether the kind of approach that you've taken might work here as well, in the sense that we may have a good set of meteorological records, but they may fill the gaps that we really need some information on. And I'd be very, very keen to be able to plug some of those gaps as well. The second question, and this is more from a paleoclimatology perspective, I saw that you have a good number of lakes and coastal lagoons. Are you aware of any paleoclimate work that's been done on San Salvador Island? I'm thinking particularly of some similarities between the kinds of lagoons that you have there and those on Barbuda. And I wonder whether we could use the kind of the ostracod or the gastropod record there to do some reconstructions of paleohydrology, essentially, to see if that could help with answering some of your questions as well.
Yeah, thank you very much. I appreciate the questions. The first question, sure. Again, it may not be perfect, but it does provide insight. And for instance, if you have a big gap between an area that's far away from an airport, somewhere that's more rural, there may not be any reason to deploy an expensive meteorological observing station or whatever. And so but there's still the need is there. Maybe there's some, agriculture or whatever that needs that data. So getting buy-in on recording the precipitation, I think is huge. It doesn't necessarily have to even be QAR. It's just, someone recording the daily rainfall amounts and being able to catalog it would be, that information is very useful. And, explaining to the community that, the reason for doing this is because we need water for so many reasons. And there's a chance that we may not have as much water as we used to. So yes, very much so. I think that's a good solution to filling gaps, as you said. Perhaps, again, not even using QARs, maybe just recording on paper, developing your own independent app or something like that. Getting to the second question, I do know that there is research. I'm not familiar with but I do know that people have done a lot of palynology of some of those lagoons and lakes. The Gerace Research Center keeps a record of who's doing research in what areas. I don't know right off the top of my head, but I'll be happy to look at their database and figure out who are the paleo folks doing that. But yeah, the depositional environment would be good for doing the paleo work. Thank you.
So just filling in, taking off from something that Mike mentioned, is that while we do have a reasonably good rainfall network, gauge network, sometimes they stop working and you do have large areas that are not getting accurate information and you have to go to the next available station. Yeah. And the variability that you mentioned in your talk between the Gerace Center and the Estates station, we can be on one part of the Mona campus and it's pouring rain, and you drive across campus and it's absolutely dry. It's not even that it's raining lightly, the ground is dry. So that short distance and the variability in rainfall happens, here as well.
Sure.
I think that there is scope, if there are interested persons, to form an informal citizen science network, maybe not only in Jamaica, but maybe other islands, because I think with climate change, water availability, some places like the Grenadine Islands have real problems, and persons, NGOs in some of these islands would be very interested in setting up some kind of citizens network to monitor rainfall in individual islands. So that
Sure.
might be something for you to explore in terms of expanding your Caribbean net.
Yeah, great. Thank you for that. And if you could maybe email me what you just said, I didn't know if I wrote it all down. I would be very happy to do that. Yeah, it's not hugely technical. It's just a rain gauge, but that information is so vital. There are a lot of people that talk about the variability anecdotally, For instance, on St. Kitts, they'll always say the sister island of Nevis is substantially drier, but there's not as much information about Nevis to compare it to. And so being able to quantify that, I think, is really important.
What would be also be interesting, as you mentioned St. Kitts and Nevis, is that there have been some older studies in terms of vegetation, biogeography, Baird's review of the Antillean Islands in terms of vegetation. I know some of the islands, St. Kitts in particular, have actually commissioned newer vegetation assessments. So it might be good, picking up on Mike's thread, look at historical vegetation distribution, what they were recorded, say like in Baird's reports, and what's happening now, and just looking at some of these changes, because it might say something about what's been happening from a climate point of view in terms of the long term.
Sure. A lot of when I was on St. Kitts and working with Clarence Fitzroy Bryant College, some of the faculty were saying that they noticed that they have two things, that it was getting drier, and the streams aren't flowing as well as they used to. But then on a human side, they said that a lot of times when it would rain, the community's downslope would flood a lot. So they did a lot of engineering to funnel that water off the island to get it into the ocean so it doesn't flood the community. And now fast forward to 2021 and 2022 and drying climates, that they need to do the opposite in retaining has been developed and gosh, since Columbus went, so my internet is unstable. Are you still?
Yes, you're okay.
So anyway, looking at the historical trends, not only looking at, the vegetation, but maybe like the channels and the geometry of the channels and how much precipitation, may have been there at one time. And then looking at kind of the historical record from the community, what do they remember? What do their grandparents remember about the precipitation?
Right. So I think what we've seen is that there are several ways of building this out, whether it be by a volunteer network for the actual rainfall information and also memory.
Mm-hmm.
I just finished a project, but it was more around food and climate change. And one of the things that we were tapping into was asking the youth participants to have conversations with their elders. And so the memory part might also be important, because I'm sure you're aware from working in the in the Bahamas, that in the Caribbean, a lot of what happens is oral records. So that might be something that would be useful to tap into.
Very much, yes, that's a great idea.
I'm scanning and I don't see any other hands or any other questions at this time. So I don't. Tom Steeman has his hand up. Go ahead, Tom.
Here. First, let's see. Here's my field hat. I don't think your field hat was. This is actually my wife's too, but this certainly works. So
thank you for that.
Yes, and one thing before you go, you certainly should. There are plenty of things you could do here in the similar ways up in Discovery Bay or Portland area. And I don't know, well, for me, what was most stunning about this is that there is variability in a place as small and with as little topography as San Sal. And I'm pretty amazed, because obviously we see quite a bit here because we've got the topography that's gonna, and certainly we do have a good record, except that there's quite a bit of variability and there could be a lot more. I would imagine one way might be linking into schools and getting them to record data. And that's one way that could work. But yeah, the idea that San Sal has as much variability as you showed is pretty impressive, because you don't usually think of it. This is a little postage stamp island now.
Yeah.
And so you're going back. I know that they've got new. I've met a lot of people who've been going down there and are now leaving because there's some added costs and so on. And I spent at a meeting was trying to convince them all to come and go to Discovery Bay instead. But yeah, although they do have, I mean, they've got more than just Gerace. They have the old College of the Finger Lakes place too.
Yeah,
yeah.
That's at Gerace. Tom Gerace.
Is this, oh, that's the same?
Yeah.
Oh, okay, that's the one. Yeah, because there's quite a bit of geology people that go down there.
Yes.
And yeah. But as I was telling you, I was trying to convince a lot of them they could come here, because there's plenty of things and plenty of opportunities you could expand. Yeah.
Can you send me the Discovery Bay? I'm not familiar with it, and I'd be interested to know what
Oh,
it
yeah,
is.
we can link to the website here on at the UE Mona website. Yeah. So yeah, I can send something like that. Yeah.
The only issue I have with schools is that, I mean, it's great, but the schools go away for the summer.
Right, that's a problem.
And a lot of times, they don't report. And truthfully, a lot of the expats, it's the same way.
Sure.
A lot of times they go back to the UK, during hurricane season, which is the time when we need we'd love to have the most information. So, but yeah, the schools are great. It's good to see the children get involved in it. I mean, that's a home run. So, but we got to figure out how to do it year round. So thank you for that.
Sorry, there is an observation and a comment from Romero Griffiths in the chat, and he says, at the Water Resources Authority, we use community observers to help us in monitoring stream gauges and stations. And he's saying, is this a viable option for rainfall? It would seem so, but you can respond. And then he has a follow-on that you mentioned that there is a small aquifer that is being overused in San Salvador. Are they willing to desalinate water there?
Okay, so these are great questions. So I have a grant to use these to measure streamfall in Barbados. I'm sorry, in St. Kitts. So just little water gauges. They weren't very expensive, about $100 or so. So that's our next thing, is to deploy those to measure the stream height. So yeah, I think that's certainly possible. Just deploying these sensors, and they may not be perfect, but it might give us insight. And so the thing that we want to do is compare the stream flow with the precipitation. What is the lag? How long does the stream continue after the precipitation event? And how high does the water get? And we're hoping to be able to get that information with these stream gauges. So that it is a possibility. The second question was with the desalinization. Okay, so I'm sure you guys are well aware of this, that when you get development of tourism, sometimes that can lead to an impact on the environment. And I'm not trying to throw the developers under the bus or anything, but I do know that on San Salvador Island, a big resort community came in and they promised to use a desalinization. And that was kind of in the original bid, is that they were going to use desalinization. That was in the 90s. And so they built the desalinization plant, but the fuel cost to run it was so expensive that instead they utilized the main aquifer for Coburn Town, which is the most populated part of San Salvador Island. It's the central population of the island. And so from what I understand is that it upconed, it's not ruined, but there's certainly a saline taste to the water. And when I was at the San Salvador airport, they would say, don't drink the water from the fountain because of that. So there is desalinization, it is possible. But the costs are real expensive. I know they're running them, they've been running them lately, but now with the price of oil being so expensive, I don't know if they're going to continue. I don't even know if Club Med's open because I haven't been there in 2 years, but I shouldn't have said the name, darn it. I don't even know if they're still running it, but it just seemed like it was a good idea, but maybe too expensive.
Okay, I'm not seeing anything else. No hands. This is your last opportunity for hands, comments, questions for Professor Rodgers. Anybody else in the audience? You can either put it in the chat or raise your hand. All right, well, Professor Rodgers.
There's a hand in the participants.
Romero Griffiths. Go ahead, Romero. Yes, he was at the
Hi, good afternoon. You hearing me?
Yes.
Everyone hearing me?
Yes, Romero, we're hearing you.
All right, good afternoon. Just another question to add to what I asked earlier. All right, I'm not sure if everyone is aware, but in Jamaica, we have an artificial recharge where we try to put fresh water back into the aquifer. Is that something that I can't remember the name of that place.
San Salvador? Yeah.
Yes, San Salvador. Is that something that they could also look into, seeing that they depend heavily on their aquifer?
That's a great question. I would be lying if I said I knew the answer. I don't know the engineering, but it seems like if you guys could do, maybe share that technology, they might be able to do it. I know that in San Salvador Island, their aquifers are relatively small in extent, and partly because they're dry islands, and so there's a lot of evaporation, and it pinches the freshwater lens into little globs instead of one continuous reservoir, and so the freshwater lenses again are in these little pockets, and so from what I understand then is that maybe it might be easier to do that because they're smaller. In other words, if you had a small little pocket and you were able to capture the rainfall and with a catchment system, then you maybe be able to pipe it back in. But again, that's above my capacity to understand. I don't know the answer. Sorry.
So Professor Rodgers, quietly you have seemed to have sparked quite a lot of interest in various participants who have messaged me directly. And some persons would like to connect with you directly. So if you don't mind sharing your email in the chat for everyone because there are a few persons who I guess want to speak to you about work in particular Caribbean areas or otherwise. So they would like to follow up with you after this afternoon.
Yeah, did I send it to everybody? No, I just sent it to one person. Hold on. Sorry, I've turned into one of those people like my parents that don't know how to use technology. Okay, yeah, John Rodgers, and I'd be glad to. I mean, one of my regrets is that I was unable to go down to the Mona campus and be there in person. I was super excited to get the email and then saw it was virtual. I was like, oh man. Maybe one day I would like to come, and so it would be a great experience. And if you want to reach out to me, please feel free to do so. I'm happy to talk with you all.
Professor Jonathan, hey, if you do get the chance to go, you thoroughly enjoy yourself.
No, well, I'm sure there's more than Ocho Rios for the island, so that's what I want to explore, and I want to try the fresh Blue Mountain coffee. I hear it's epic. So
if you do get here, we'll arrange the coffee. We'll arrange a coffee farm tour and some coffee for you because the department has done quite a lot of research in coffee and with coffee farmers. So we'll sort of arrange that.
Yay.
I don't know if our HOD has anything to say. Dr. Campbell, do you have anything to say at this point?
No, I mean, it's a wonderful presentation.
Thank you.
Prof, really enjoyed it. And, we look into a few opportunities in the near future to bring you over here, so thanks for putting that on the table. Yeah.
Fantastic.
Yeah, man. Thank you for a very good talk. Yeah.
Thank you.
All right. Well, it's for me to follow on and to add my own thanks on behalf of the Department of Geography and Geology and the Quality Assurance Unit. Anna was represented here this afternoon, Perkins by the as a representative of the Quality Assurance Unit, and to thank all the participants who have joined from as far south as Trinidad, and we have persons from Antigua. I'm not sure if I'm missing any of the other territories who may have joined in. And we have some of our past students who are now working in industry, like Romero Griffiths. And we have graduate students, staff. And so you've had a pretty mixed bag in the audience today, and it was our pleasure to have heard. And as you can see by the discussion after, you did spark a lot of interest and potential collaborations, follow-on activities. So thank you so much for a very engaging.
My pleasure. Thank you. Thank you all.
Thank you. And thank the audience once again.
Yes, thank you guys. I appreciate it.
Good afternoon, everyone.
And Anna, of course, in the chat, Anna Kasafi Perkins has noted her own thanks. Bye, everyone. Good seeing you.
Okay. Dr.